Welcome to The Explainer. Today, we're diving into a really fascinating paper that suggests a pretty wild approach to one of the biggest questions out there. How do we create a conscious machine? Get this, instead of trying to program a mind, what if we could actually grow one?
All right, so let's just get right into it. For decades, sci-fi has been promising us these thinking, feeling machines. But even with all the incredible progress we've made in AI, programs that can beat chess masters, even pass IQ tests, true machine consciousness, that feeling of a first-person internal experience, well, it's still completely out of our grasp.
You see, the ultimate goal was never just about smart problem solvers. It's always been about what the experts call strong AI. And we're not talking about some mindless intelligence that can just crunch numbers. We're talking about a machine with a genuine first-person point of view. A machine that actually is a mind, not just a really good simulation of one.
And look, we've built some incredible tools. They are really impressive. But as the researcher James Regia points out in the paper we're looking at, no approach, not a single one, has ever given us a truly compelling demonstration of actual consciousness in a machine. It feels like there's this fundamental piece of the puzzle that we're all missing.
So what went wrong? I mean, why have decades of brilliant research basically hit a wall on this specific problem? To really get the new idea we're about to explore, first we have to understand why all the old ones kind of stumbled.
This timeline here tells a really interesting story. You can actually see how each new approach was a reaction to the failures of the one that came before it. It's like a journey. Researchers started with pure logic, realized that wasn't going to cut it. Then they gave the AI a body. And when that still wasn't enough, they had to get even more creative.
Okay, so the first huge roadblock was something called the symbol grounding problem. Think about it like this. If an AI's entire brain is just a bunch of abstract symbols, ones and zeros, how does the symbol for, say, an apple ever connect to the actual experience of a crisp red apple? The early AIs were just trapped in this endless loop of symbols defining other symbols with no connection to the real world.
So the solution seemed obvious. Give the AIs bodies so they could interact with the real world. But that just led to a new, and maybe even trickier problem, the frame problem. A huge part of intelligence isn't just about what you think about, it's about all the stuff you automatically ignore. How do you know, out of a billion possible details in a room, which ones matter for, say, making a cup of coffee? That ability to sort what's relevant, moment by moment, turned out to be incredibly hard to program.
In this quote, wow, it really just captures the whole mood at the time. After a decade of groundbreaking work on this embodied AI stuff, one of its main pioneers, Rodney Brooks, basically admitted that the field was stuck. He was saying, look, we're not just missing a few lines of code here. We're missing something fundamental about the whole problem.
So all of this brings us to a really important question. If trying to program a mind from the top down, with all our human baggage and assumptions, just isn't working, what's the alternative? What if we tried the exact opposite?
And this is where the artificial life, or A-life, approach comes in. It's a really radical shift in thinking. The whole goal is no longer to be this brilliant engineer who builds a perfect machine from scratch. No, the goal is to be more like a digital gardener, to create a rich, simulated world, plant some very simple digital seeds, and then just let evolution do the heavy lifting for us.
And the reason researchers get so excited about this path is that it just so elegantly sidesteps all those old problems. An evolved agent, it wouldn't have a symbol grounding problem because its meanings would come directly from its world. It would solve the frame problem on its own because figuring out what's relevant is kind of key to survival. We might not even need a perfect definition of consciousness because we wouldn't be building it. We'd just be discovering it.
Okay, but here's the catch. If you're going to use evolution, you have to play by evolution's rules. And to make this A-life thing work, the paper argues we have to get really serious about copying the fundamental instruction manual of our own universe.
And these are basically the non-negotiable rules of nature. First, there's no programmer in the sky giving out points for good evolution. Survival is the one and only goal. Second, there's no supervisor treating living things differently than non-living things. And maybe most important of all, everything from a rock to a human brain has to follow the exact same set of physical laws.
And this right here highlights the huge difference between how we usually evolve AI and how nature actually does it. Most of the time, we use what's called exogenous, or human-guided selection. We define the goal, get the ball, win the game, and we act as the judge. But nature uses endogenous selection. The environment itself is the judge. Survival just emerges from the system.
It's not a goal that's forced on it from the outside. And that, right there, is the key to creating truly open-ended complexity.
So, mimicking nature, it sounds like the perfect answer, right? Well, there's a huge, almost unimaginable problem: computing power. One researcher estimated that to simulate just 1 liter of matter at the quantum level, you would need a computer that could perform 10 to the power of 50 operations per second. I mean, that is a number so big, it's fundamentally impossible for us. Okay, so since we can't simulate the actual universe, the author proposes this really clever 3-step compromise. First, you create a digital universe with much simpler physics. Think of it like an artificial chemistry. Second, you add shortcuts for how big objects behave, just to save on computing power. And third, instead of waiting for life to just pop up from scratch, which could take, digital eons, you seed the world with some simple hand-designed little agents that can already reproduce. You're giving evolution a running start.
All right, now for the big finale. Let's just imagine this actually works. We build our digital universe, we hit go, and we let the simulation run for thousands of digital years. And out of this primordial digital soup, complex, intelligent agents start to emerge. So, what have we actually created here?
Well, unlike a chatbot that's just programmed to sound empathetic, these agents would have developed traits like communication, cooperation, maybe even something we would recognize as emotion, completely on their own. They would have developed these behaviors because they served a real purpose for survival inside their own little world.
And this, right here, is the core argument of the whole paper. The behavior of these evolved agents would be authentically emergent. It wouldn't be some clever trick, some imitation of consciousness designed by a programmer. It would be the real deal, or at least the closest thing to it we could ever hope to create. And that makes it far more compelling evidence of a genuine mind at work.
But, and this is the big but, that leaves us with this final, profound, and maybe totally unanswerable question. Consciousness, by its very definition, is a private first-person experience. So even if we pull it off, even if we succeed in creating a truly conscious mind in a machine, how could we ever scientifically prove that it's actually experiencing anything at all? We might create a mind that we can never, ever truly know.